Welcome back to the next lecture of Transistor lecture series. Here we are going to explore the characteristics of common base transistor configuration. So in our previous discussion, we have seen the common base configuration. So here it is shown for NPN and PNP transistor both. Now for common base configuration, we have analyzed the input section and output section, and we have found the input current as IE, input voltage as VBE, or many times it is written as VEB also. So both we can consider. Output voltage as VCB and output current as IC. Now on the basis of that, from the input loop we have found the equation VEE equal to IE into RE plus VEB. So from this loop we have found this equation, so we may consider this as the input equation. Similarly, from the output loop we have found the output equation as VCC, that is equal to ICRC into plus VCB. So this is what we have the input and output parameters as well as input and output equation. Now to find the input characteristics, what we need to do? So input characteristics, it is the variation of input current IE versus the input current VEB. So variation of IE against input voltage, keeping output voltage VCB constant. So under constant VCB, what is the variation of the input current is called the input characteristics of CB configuration. So if we see that input voltage is VEB and input current is IE. So the variation will be just like a diode. So here suppose this is VCB equal to 1 volt. Now if we increase VCB, we'll be getting this kind of thing, like suppose this is VCB equal to say 5 volt. Now if we further increase the VCB, then we'll be getting, so it will be going towards more and more ideal values, and suppose this is VCB say 15 volt. Okay, just for example I have shown. So if we have VCB very high, then we'll be having even stiffer slope. And here if we see that the resistance of the transistor, input resistance of the transistor, that is Ri, that is equal to change in voltage with respect to the change in current, keeping VCB constant. Now here if we see that the input resistance, for a very small change in the voltage, IE changes drastically. So as a result of that, input resistance of a transistor always tend to be very small. It is in terms of few ohms only. So that is the input resistance, and we can find it from the input characteristics of the common base transistor configuration. So now next is the output characteristics. Now output characteristics is defined the variation of the output current IC against the variation of output voltage VCB, keeping input current IE constant. So that is the output characteristics. So if we plot these we get this kind of thing. Say this is VCB in volts, this is IC in normally in milliampere. In previous case also IE was also in the milliampere range. So here also you can write in terms of milliampere and this is in terms of volts. So here if we plot it, we can see that for very small value of IE, we'll be getting this kind of uh, graph. So say IE here, for example, maybe 1 milliampere. Now if we keep on increasing IE, then we'll be getting IC equally higher values, and then that will be flat. So this kind of, say this is IE equal to say 5 milliampere, here IE equal to say 10 milliampere, IE equal to say 20 milliampere, and so on. So this kind of output characteristics we can see, and from here you can see that the variation in voltage, for very higher variation of voltage here in this particular region, current is not changing much. So we can say that output resistance, which is delta IC by delta uh, uh, so here this is delta VCB. Okay, so voltage by current. So delta VCB and this is delta IC. So that means variation in voltage which is quite high compared to the variation in current. So as a result of that, output resistance of the transistor is high. So in terms of hundreds of kilo ohms or even more. Now these regions, if we analyze, you can see that there are three regions. So the region, in this region we call it saturation region. Saturation region. This region we say active region, and this region we say cutoff region. So these are the three different region of these characteristics. Now in the active region, the base emitter junction JE, here the JE, and collector base junction JC. So this is in forward bias, emitter junction in forward bias, and collector base junction, that is in the reverse bias in the active region. Now here in the saturation region, both the junction JE and JC are forward bias, and in the cutoff region both are in the reverse bias. So that is the relation, both are in the reverse bias condition. So depending on this situation, if my transistor, if I can switch between saturation and cutoff region, then transistor will work as a switch. And if we are working in the active region of the transistor, then transistor we can use as an amplifier. So this is about the input and output characteristics of the common base configuration. So here we end this discussion. Thank you very much.